Amperes frame, often abbreviated as AF, refers to the frame size of the circuit breaker. The frame size dictates the physical dimensions of the breaker and its ability to dissipate heat. A larger frame size generally indicates that the breaker is designed to handle higher continuous current. It's important to note that the Amperes frame rating doesn't necessarily reflect the actual current the breaker is set to trip at, but rather the maximum current the breaker can safely conduct continuously without overheating or failing. Think of the frame size as the foundation upon which the other ratings are built. It sets the stage for the overall performance and capabilities of the circuit breaker. When selecting a circuit breaker, the Amperes frame rating should be carefully considered to ensure that the breaker is appropriately sized for the application. Selecting a breaker with an inadequate frame size can lead to premature failure, overheating, and potentially hazardous conditions. The Amperes Short Circuit rating, or AS, indicates the circuit breaker's ability to interrupt a short circuit current. A short circuit is an abnormal condition in an electrical circuit where current bypasses the intended load and flows through a low resistance path. This results in a rapid and substantial increase in current, which can quickly damage equipment and pose a safety hazard. The Amperes short circuit rating specifies the maximum short circuit current that the breaker can safely interrupt without sustaining damage or failing catastrophically. This rating is typically expressed in kiloamps, or kA. When a short circuit occurs, the circuit breaker must quickly and effectively interrupt the flow of current to prevent damage to the electrical system and equipment. The Amperes short circuit rating determines the breaker's ability to perform this crucial function. Selecting a circuit breaker with an insufficient Amperes short circuit rating can have serious consequences. If the short circuit current exceeds the breaker's interrupting capacity, the breaker may fail to interrupt the current, leading to arcing, equipment damage, and potential fire hazards. Therefore, it's essential to select a circuit breaker with an Amperes short circuit rating that is adequate for the anticipated short circuit current at the installation location. This requires careful calculation and consideration of the electrical system's characteristics, including the available fault current from the power source and the impedance of the circuit. Amperes Trip, or AT, is the current at which the circuit breaker is designed to trip, thereby opening the circuit. This is also sometimes referred to as the breaker's ampere rating. When the current flowing through the circuit exceeds the Amperes trip rating, the breaker's internal mechanism is activated, causing it to trip and interrupt the current flow. The Amperes trip rating is a critical parameter that determines the breaker's ability to protect the circuit and equipment from overloads. Overloads occur when the current flowing through a circuit exceeds its normal operating current, but not to the extent of a short circuit. Overloads can be caused by various factors, such as excessive loads on the circuit, faulty equipment, or improper wiring. The Amperes trip rating is carefully selected to match the current carrying capacity of the circuit conductors and the equipment connected to the circuit. This ensures that the breaker will trip and protect the circuit from damage in the event of an overload. Circuit breakers typically have an inverse time characteristic, meaning that the tripping time is inversely proportional to the magnitude of the overcurrent. In other words, the higher the overcurrent, the faster the breaker will trip. This inverse time characteristic allows the breaker to tolerate brief, harmless overcurrents, such as those that occur when starting a motor, while still providing protection against sustained overloads. The Amperes trip rating is a fundamental parameter that must be carefully considered when selecting a circuit breaker. Selecting a breaker with an inappropriate Amperes trip rating can lead to nuisance tripping or inadequate protection against overloads. For example, if the Amperes trip rating is too low, the breaker may trip unnecessarily due to normal current fluctuations. Conversely, if the Amperes trip rating is too high, the breaker may not trip quickly enough to protect the circuit and equipment from damage during an overload. In summary, the Amperes frame dictates the breaker's physical size and heat dissipation capacity. The Amperes short circuit indicates its ability to interrupt short circuit currents, and the Amperes trip specifies the current at which it will trip to protect against overloads. When selecting a circuit breaker, all three ratings must be carefully considered to ensure that the breaker is appropriately sized and capable of providing adequate protection for the electrical system and equipment. The interplay between these ratings is crucial for ensuring the safe and reliable operation of electrical circuits.